Hey everybody, this is Chapter 5, Section 8. Title is Graphing Absolute Value Functions. Starts on page 342. This lesson, very short notes, several examples, and that should be it. Shouldn't take much at all. We learned in Chapter 4 that the graph of an absolute value function is V-shaped, or it can be upside down V-shaped. We'll use that information again today. A translation is when you slide a graph up, down, left, or right by adding something or subtracting something to your equation. So we're going to take the absolute value function and translate it. We're going to slide it up, down, left, and right on our graphs. Where you slide your graph depends on where the number is in the problem, and I'll give you those details here in a second. When you slide a graph, when you do a translation, the shape and size of the graph stay the same, but the position changes. So, the normal absolute value graph is V-shaped, just like that. Okay? So when we translate these graphs, we're going to keep the same shape. All we're doing is we're moving around where this point goes, where the point at the bottom ends up. Okay, you'll see that in a second. Now, we said it depends on the numbers. Here's the rules for what that's telling us. If you add a number on the outside of the absolute value bar, the graph will slide up. If you subtract a number on the outside, the graph slides down. Okay, so there's your important words. Add on the outside goes up. Subtract on the outside goes down, and I'll give you examples of each one of those. If you add a number on the inside, the graph slides to the left. Now, that's a little bit backwards, because you're adding a number, which means you're going to have a plus something, but the graph is going to where the numbers are negative. The numbers are negative on the left. So that seems a little bit backwards. Last one, if you subtract a number on the inside, the graph slides to the right. So what do I mean by like inside and outside? So adding a number on the outside of the bars, okay? So you're going to have absolute value of x, and we're going to add something to the outside of the bars. That's what that would be like. If I added something to the inside of the bars, it would look like that. That's the difference between outside and inside. Hopefully you know the difference between add and subtract. Okay? Those are all the notes. That's everything you need to know. Everything else in this section is just example problems. Different things that we can do with it. Example 2, we skip example 1. It says, what is the graph of y equals absolute value of x with a minus 7 on the outside? Now, I added this line here just to help you remember. Go back to your last screen of notes. Subtract 7 on the outside of the bars means go where? Well, if you go back a slide to the notes, subtracting 7 on the outside means that you're going to move down. All right? So I'm going to go down to where negative 7 is. That's right here. And I'm going to draw my V shape. It doesn't really matter where where these lines go, as long as they're spread out from each other. I mean, you don't want it to be like this, super close together. You don't want it to be like this, super far apart. You want it to be kind of in the middle. You don't want it to be really narrow. You don't want it to be fat. You want it to be kind of in the middle. Okay, that's good enough. Now, we could actually figure out where the ends of this arrow is supposed to go, but that's not the point of this lesson. All I want you to know is that when there's a subtract 7 on the outside, that means that the point, the end of your graph, ends up down 7 places. Okay? One for you, y equals absolute value of x plus 3. Add 3 on the outside means do what? Put it in there, and then graph. Another type of problem. If I move the absolute value up 8 places, what does that do to my equation? So up 8, go back to your notes. The notes say that in order to go up, you have to add on the outside. So the equation to go up 8 you add to the outside. So I'm going to have a plus 8 over there. Okay? Plus 8 on the outside means go up. What is the equation when I move the graph down 5 places? In order to go down, I need to subtract on the outside of the bars. So there's my bars, and on the outside I need to subtract 5. And those are the equations that I would get. Two of the same things for you. You've got one going up 9, you've got one going down 1. Figure out what happens to the equations. Next one. This one, we're subtracting 5, but we're doing it inside the bars. Subtracting 5 on the inside of the bars means do what? Well, if you go back to your notes, subtracting on the inside means you're going to go to the right. So, I'm going to start at the origin. I'm going to go to the right 5 places, and then I'm going to draw my V shape. Just like that. One for you. If I add 3 on the inside, where do I go? And then graph it. What is the equation? What happens to the equation when I move the absolute value graph to the right 8? Well, to the right 8, right means I subtract on the inside of the bars. So there's my bars, and I'm going to subtract 8 on the inside. Right means subtract on the inside. What is the equation when I go left 6? Left is add on the inside. So I get y equals absolute value of x plus 6. Okay. Up and down happens on the outside the bars. Left and right happens inside the bars. 2 of those for you to try. A negative sign in front of the bars means flip the graph over. So negative sign means flip the graph over. So if I have this graph, y equals negative absolute value of x minus 3, subtracting 3 on the outside, we already did that. Subtracting on the outside means go down. The negative sign in front means to flip it. So I'm going to go down 3 places, and I'm going to flip my graph over. And that's what it would look like. Down 3 places, and then flip the whole thing over. For you, you're going to add 3 on the inside. There's a negative sign. So adding 3 tells you to do what? Negative sign tells you to do what? And then graph it. One more thing, you can do more than one movement at the same time. Instead of just going up or down, or just going left and right, you can do up and left, for example, down and to the right. So you can do 2 things at the same time. Subtracting 1 on the inside means go to the right. Adding 2 on the outside, adding on the outside means go up. It's just stuff that you're going to have to remember there. So I'm going to start at the origin, and I'm going to go to the right 1. I'm going to go up 2. Okay, so there's 1, 2, 3, 4, 1, 2, 3, 4, 1, and 1. So I go to the right 1, up 2, and that's where I put my dot. Is there a negative sign in front of this one? No, there isn't, so my B is going to stay going up instead of flipped over. Okay, so I can do more than one at the same time. I can go to the right and up at the same time. So I went 1 to the right, 2 up, and then I drew my V shape. One for you to try just like that. Subtracting 1 on the outside tells you to do something. Adding 2 on the inside tells you to do something. There's no negative sign out in front of that problem, so it's going to stay right side up. Spot for questions, concerns, and comments.